I want to sketch a graph of this thing. 6 plus 8x squared minus x to the fourth. I don't have a calculator. Well, that's a lie. I have one right here. But let's say I don't. All right. Right. I'm on a deserted island. Okay, so f prime of x.
All you have is a basic pocket calculator.
That's right. So here I have 16x minus 4x cubed. Right? That's the derivative. And so you guys all factored that by taking out the 4x, and you got 4, because 4x times 4 is 16x, minus x squared. And then you said, ha, that's a difference of squares. So f prime of x is 4x times 2 plus x times 2 minus x. And so you guys told me, as I walked around, hey, I know the critical values. The critical values are 0, negative 2, and positive 2, coming from those factors. This is what I saw on your paper. And so I saw you guys doing it. I saw you guys draw on the number line. And I saw you put 0 on the number line, and you put 2 on the number line, and you put negative 2 on the number line. And then I saw you guys picking test points like 1. And so I saw people computing f prime of 1. And so you threw a 1 in there, and you got a positive, and a positive, and you said it's positive. Right? And so since f prime is positive, that means f of x is increasing. Right? And over here, you guys did things like f prime of 3. And when I plug in a 3, I get positive, positive, but what happens here? You get a negative. So it's negative. And that means f of x is decreasing. By the way, what does that tell me about 2? It tells me that at x equals 2, we have a relative what? Maximum. That's what the first derivative test tells me about that. Because it's going up, then it's coming down. You guys with me? Okay. I believe that if you test things like negative 1, you get negative, positive, negative. And so, let's see, try that again. Negative, positive, oh, positive. Negative, positive, positive. So what I'm getting for the rest of this is that f prime of negative 1 is negative, and I'm getting f prime of negative 1,000, or whatever you might put in, is positive. And so I claim that the graph kind of does that. Are you with me? Okay, so again, I'm on deserted island without a graphing calculator, and I say I want to sketch the graph. I'll tell you what I should do. I should compute certain values. And the values I'm going to compute, well, let me make a little list here. I'm going to have x, and I'm going to have f of x. And then, once I have those computed, I'll be able to sketch a graph over here. And the x's that I think are important to compute are these critical values. So let me throw in 0 and negative 2 and positive 2. Into the function. Remember, f of x is 6 plus 8x squared minus x to the fourth. Or you can write it this way. 4x times, oh no, that's not it. It's just this. Okay, so when I plug in 0, I'm getting 6. You guys with me? So the y-intercept is 0, 6. And then if I plug in negative 2 or positive 2, I'm going to get the exact same thing for the function. See, I'm trying to graph the function now, so I need to plot points. Did you guys notice? I was working with the derivative. Now I'm graphing the function. Because that's what it said to do. It said sketch the graph of a function without a calculator. No calculator's been used yet at all. Okay, let's see if I can compute one of these. How about f of 2? F of 2 is 6 plus 8 times 4 is 32. Look at that, no calculator. Isn't that impressive? Minus 2 to the 4. 16, and that's without a calculator. Round of applause. Thank you. There'll be more mental math a little later today. All right, so let's see. 38 minus 16. I'm getting 22, right? Thanks, Nikki. All right, so here I have, I will not quit my day job, 0, 6. Here I have 222, and here I have -2 would also give me an output of 22. So I claim the graph looks something like this. Dun 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 dun. Dun 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 dun. Dun 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 dun. Dun 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 dun. Something like that. Right? Nikki?
I have a question.
Yeah.
So when I took the derivatives,
Yeah.
I kind of flipped them so they were in like degree order.
Uh-huh.
So when I factored it, I pulled out a negative 4x.
You could, and if you do,
Answer that.
well, if you do, your derivative will look like this. If you do it correctly, your derivative would look like, and where should I write it? Boy. Maybe over here on the side. So another way to do this would be to say that f prime of x is -4x times, it would be x minus 2 times x plus 2. Is that what you got?
Yeah.
It works. You can do that.
Doesn't it make your graph different when you get...
Shouldn't. For example, remember I got that f prime of 1 was positive right here at the bottom. Let me try it on your derivative and see if that still works. F prime of 1 is -4 times -1 times -3 times +1, right? Oh, hang on.
Yeah.
-4, oh, times +1, sorry. I'm doing f prime of +1. -4 times +1 times -3 times, I'm still getting that it's positive.
For the like last one, so if you were to plug in like a +3,
If I plug in +3, I get negative, positive, positive, positive. So it's negative.
okay.
They're just plugging in problems. That's what that is. Other questions? You guys getting this? How do you like my graph? I mean, one thing, thank you. One thing is, I guess I didn't really explain, here's 2 important points on the graph that someone might want to know about, right? See those blue points? Would I be able to find those? How would I do it? I'd have to solve what equation? F of x.
X equals 0.
Yeah. Would you guys know how to solve that equation? I mean, you could factor out you could divide both sides by -1, and you get x to the 4th minus 8x squared minus 6 is 0. I think you can do things like this. Oh no, that doesn't work. You could use the quadratic formula to get x squared. Yeah, let's not go there. All right. But there's things you could do. All right, let's move on. Let's talk first derivative test rather than algebra. So number 2, I'm going to move a little bit more slowly this time because people sort of got this one. Okay. One thing that helps, you guys do understand that what this really says is this. You guys agree? That's the same thing. So when I do the derivative, bing, right? And then, bing, to what power? To the first power. And then what? Bong. So we have to multiply by something. By the derivative of the inner function. What's the derivative of the inner function? Negative sine of x. So I'm claiming that our derivative is f prime of x is -2, and actually how most people would write it is sine x cosine x. And I don't know why. Why do people put sines before cosines? I have no idea, but that's how people write it. Okay, so I want to find the critical values so I can do the first derivative test. And that means I need to find places where the derivative is equal to 0 or undefined. Is this thing ever undefined? Sines and cosines, you can find sine and cosine of anything. So what I really need to do is solve equations like sine of x equals 0 and cosine of x equals 0. And I have to figure out where that happens. Well, you know, I'm going to draw a number line, but I need to figure out where it happens, say, between negative pi over 2, because notice that's the open interval we're working on, all the way up to 3 pi over 2. Okay, let's solve one of these equations. Sine of x equals 0. Can you give me an angle that I could put in and get a sine of 0? 0. The sine of 0 is 0. So one of the possibilities is x equals 0. That's going to be a critical point. Any others? X equals pi is another one. What about pi over 2? That'll make the cosine 0, right? So I'm going to put in things like 0 and pi over 2 and pi. Those are my critical values. How we doing, okay? So those are the critical values. So I'll be honest, I don't know what cosine of x squared looks like. Although I do know it's going to be, everything's going to be above the x-axis, right? It's going to be positive. Well, it's going to be between 0 and what's the highest that it'll ever get? 1, because 1 squared is 1, and fractions squared stays fractions, right? So I'm getting an idea what it's going to look like. I guess I'm wondering, where do we have relative maximums or relative minimums? So did you guys try any particular test values? I think if I were doing it, I'd pick this one first. And I would plug in pi over 4. Because pi over 4 is very special. You know, again, you're on a deserted island. You have no calculator. Remember? Without a calculator. If you don't have a calculator, how the heck do you do trigonometry? Well, hopefully your trig teacher told you that if you want to know about the sine and cosine, you need to study, what is this called? The unit circle, right? You guys with me? So when I want to talk about pi over 4, that's right here. And that's one of those famous points we memorized. You remember? Radical 2 over 2, radical 2 over 2. Yes? Okay? So that means that f prime of that is negative 2 times radical 2 over 2 times radical 2 over 2. Is it negative or positive? Negative 2 times that times that. So it's going to be negative. It's going to be negative. Negative 2 times positive this times positive this. You guys with me? What if I were to do negative pi over 4? Well, let's look on the unit circle and see what changed. That is this green line right here. The only thing that changed is that, oh no, this is still positive. It's the other one that's negative. This is positive, that's negative. So I'm going to have negative, negative, positive. That's positive. Cool. What about between pi over 2 and pi? Well, that's going to be over here. Let me draw it in black. So say, for example, I had negative radical 2 over 2, positive radical 2 over 2. So I'm going to have negative, positive, negative, which is positive. Hey, it's going to go positive, negative, positive. Am I right that this one's going to be negative? Does it always alternate like that? Positive, negative, positive, negative. No! Remember? Don't fall. Right? Here was an example beginning of class where it went negative, positive, positive. Remember the graph was kind of flat? You don't always have relative maxes or mins at critical values. It could do this kind of thing. Keep that in mind. But in this example, yes, this is what it does. So what's it mean? It means at 0, I have a relative Let's see. It's going up. It's coming down. So at 0, I have a relative maximum. You see how the first derivative test works? I think we got it. Hey, electricity has returned, and we have calculators. Let's try it. Let's graph. I want to see how good this test was. Let's graph. Well, I'm not going to graph it. I'm going to use parentheses, and I'm going to type in the cosine of x, and then I'll close parentheses for the cosine. I'll close another parentheses, and then I'll put a squared, and I'm going to graph it. But I'm going to graph it on Zoom Trig, choice 7, because that's pretty good. Okay. You guys with me? By the way, what mode am I in? Am I in degree mode, or am I in... I'm in radian mode. That's cool. What's my window? Oh, it's going from negative 2 pi to positive 2 pi. That's like more than I wanted. I guess if I really want to know what it looks like, I want to go from negative pi divided by 2 to positive 3 pi over 2. Right? And what about y min and y max? Well, we know it's all going to go between 0 and 1. I may as well just stretch it out a little bit so you can see it better. Let's graph it. Oh, there it is. That's the graph of cosine squared. Notice the cosine of 0 is 1, and notice that's a maximum. Right? So maybe we learned something today. We tried.